Welcome to my channel. My name is Opubo. For those of you new to the channel, I wish you welcome. For those of you returning, I bid you welcome back. Good to have you return. You are well appreciated. As always in this channel, I present ideas and designs of various technologies, mostly from the Technology IP Bank of Enhanced Knowledge LLC, often integrated from several other technologies already in the IP Bank by the Adoption Brokerage Division and accordingly made available. This presentation focuses on GGS methanol process technology. It is a technology that is geared towards conservation economy. The technology focuses on the utilization of methane and carbon dioxide captured from the previous two video presentations. The links are placed below in the link top section for reference. This is consistent with the goal of conservation economy, that is, the desire to find a utilization for every form of matter. And of course, the focus also includes establishing approaches that the citizens of a geographical space, participants of the conservation economy, may adopt to use the technology as to ensure the sustaining of the conservation economy. Needless to state, there is no gainsaying that the utilization of the carbon dioxide and methane, the two main gases deemed the culprit of global warming and climate change, without admitting to or refusing to accept prevalence of the circumstances, certainly goes a long way to affect a form of sequestration. However, if in some future date one determines that such concerns were unfounded, then no harm done. After all, the utilization of the gases is likely to have some return on the investment on the utilization. Addressing, however, for a moment, before making a deep dive into the utilization of the greenhouse gases that prevails in inadvertently their sequestrations. If you have not as yet subscribed to the channel by simply clicking on the subscribe button below, I implore you to do so. Please click the subscribe button now. The subscription would cause the system to keep you informed by notification of the next presentation the moment one is published. And also, of course, help me to more consistently continue to present these videos to elicit the dividend of conservation economy. Now, back to the presentation. By the current civilization, and also supported by the existence lifestyle, carbon dioxide has been produced in large quantities for years from the burning of fossil fuel, but also always just vented into the atmosphere, effectively making the atmosphere and the ecosystem a vast reservoir of the gases. And now, with a mining mechanism in place, it only makes sense to consider the technology for utilization. So the process technology design will have utilization of carbon dioxide as the raw material as key specification. A technology, GGS methanol process technology, integrated out of the technologies of the in the Technology IP Bank, which under carefully programmed conditions ignites reactions involving carbon dioxide and methane, is as shown in the figure. Conceptually, the technology, according to the program, ignites reactions between methane and steam, and between steam and methane, and between methane and carbon dioxide, with the end result being the production of methanol. By design, the technology consists of thermosiphon reboiler, programmable chemical reactor, cooler condenser, air gas separation unit operations, distillation system, methanol storage tank, and gas mixer. Looking at the image, the equipment at the leftmost lower corner is the thermosiphon reboiler. Slightly above it, in a sort of juxtaposed position, is the cooler condenser. Further to the right of the cooler condenser is the distillation column with the boiler below it. Further to the right is the methanol storage tank, and below that is the air gas separation unit operations. And finally, right smack in the middle lower is the programmable chemical reactor with program stored in the base. This is our unique advanced technology in the chemical engineering field. During operation, methane and carbon dioxide fed through the lines to the left from storage tanks not shown are mixed with steam in the mixer and fed into the reactor, where the reaction occurs between the methane and carbon dioxide and steam producing methanol, and of course some leftover inlet gases. The output flows into the cooler condenser, where the methanol and the leftover steam are condensed and collected, while the gases flow out at the top outlet and are sent to the air gas separation unit operations for re-separation and then recycle back to the respective storage tanks for subsequent reuse. The condensed liquid mixture of methanol and water is pumped into the distillation boiler, which boils up the fluid and sends the vapor into the distillation column that separates the methanol and the steam, each of which is condensed in a condenser fixed to the column, though not shown here. The methanol is of course pumped into the methanol storage tank for sale to the chemical industry. Admittedly, there is at this juncture of the presentation a uniform acceptance that the technology as presented completely meets the requirements of a geographical space that practices conservation economy with respect to the utilization of carbon dioxide, as well just vented as waste to produce methanol that is a useful product. Clearly, the rancor between nations and people all about the green energy and fossil fuel divide is resolved by this technology, which produces industrial chemicals as raw materials for the chemical industry. Given this technology, the fossil fuel industries can keep operating while the world gradually transitions into green energy use, because very simply, the effluent carbon dioxide gases could be captured and utilized as raw material for this technology. Meanwhile, the green energy sector can also extract atmospheric carbon dioxide as raw material for this technology and consequentially mitigate and even reverse the evolving catastrophic consequences to life. In effect, this technology offers everyone and every side of the divide a win outcome, making the situation a win-win. Particularly noteworthy is that even the already sequestrated carbon dioxide produced from fossil fuel burner power generators can get pumped out for utilization as raw material yet again for this technology, which leaves an outcome that prevents the potential of gases leaking out and forming ground-level carbon dioxide cloud and killing people. If interested in licensing this technology, please send an email to me. The email address is put in the pin linked below, as are other useful information. Regarding licensing considerations, there are some notes that should be of interest. The GGS characterization is a classification of the chemical processes of the type just presented. And though the GGS literally means greenhouse gases sequestration, the usage in this case implies the adoption and performance of the sequestration by reacting the two gases to produce a marketable industrial chemical. On that note, I wrap up and I thank you for being here, and I appreciate your coming to listen and view the presentation. I hope and expect that you would consider coming back for the rest of the future technology presentations. The fact is, even if you do not adopt the technologies or any of them, some might just change your perspective of society and life. Until the next presentation, I wish you be well.